Good morning, my YouTube viewers. Crystal here. What I wanted to do is I wanted to do a code review on the Analytics Vid Haya course for Twitter sentiment analysis. And basically, I took the course for free. I really only take free courses because one of the things that I've noticed when I'm taking these online courses is quite often the code doesn't work. And I don't see the point in paying money to take a course when the code doesn't work. So what I wanted to do is I wanted to do code review of this course to let you know my findings about what happened. So the first thing we did was this is the course right here. So everybody knows that I'm not plagiarizing. And first thing we do is we import the libraries. And then we import our files. So we imported the training file, the testing file, and the sample submission. So here's a picture of the training file. And then, so in the training file, you wanted to check for any racist tweets. Okay. And so they're showing racist tweets. Racist sexist tweets are 0, and non-racist sexist tweets are 1. And then what they wanted to do is they wanted to check for any non-racist sexist tweets. So we wanted to see the shape of the two files. We wanted to see the value counts, like which tweets were racist and sexist and which tweets were non-racist and sexist. So I believe they said that racist and sexist tweets are 1. So there were more non-racist sexist tweets than racist sexist tweets. So you wanted to compare the two types of tweets against each other. And so the blue is the trained tweets and the amber is the test tweets. So there were less test tweets than blue tweets. Less test tweets than trained tweets. And then you wanted to combine the train test and test files. So what they did was they appended the test file to the train file, and that's how they did it. So they wanted to remove patterns from the tweets. So this is the definition that they used to remove the pattern. So function. So they removed user handles from the tweets. They removed special characters from the tweets. They removed short words from the tweets, and they had an internally generated function called lambda as well. And so you can see the tweets after they tidied them up and removed these. So they wanted to split a stream of text tokens into the tweets. They wanted to normalize tokenized tweets. They wanted to put the tweets back together. And they wanted to put all tweets in a mosaic. So you can see all the tweets were in this mosaic. The big words are the most frequently used words. And then the small words are the less frequently used words. So they wanted a mosaic of all the positive tweets and a mosaic of all the negative tweets. So they defined a function to extract the hashtags. So they extracted the hashtags from the racist tweets. They extracted the hashtags from the non-racist tweets. And they did some more work. So now what they wanted to do is they wanted to make a chart of the non-racist sexist tweets, so you can see the main words in the non-racist sexist tweets. And then they made a chart of the racist sexist tweets, so you can see the chart of the racist sexist tweets. So they wanted to convert text to features. and they got some more work where they vectorized the tweets, and then they tokenized the tweets. And so this is just an example of word vectors. I could put anything in there like positive for Trump to show you. I'll see if it'll work. Hope it works. So I could put the word love in there. It may or may not work, so I may have messed up this file because it takes ages to get it to work. I don't think it's going to work. Oh, it's done something. It went into error, but if it had been running, because obviously it's not running because I did it last night and it took absolutely ages for it to run, then it would give you a whole bunch of words related to love. So now we've got another function where take advantage of vectors in the words. You've got another function of word vec and putting the words in arrays. Now what you do is you do doc2vec embedding, and you labelize each token tweet. And then so you have labeled tweets, and so they give you example of labeled sentences and tweets. So now you have train doc2vec model, and this was a really long function to run. So it's preparing doc2vecs, that's vectors. You have something called train bow, and so what you're doing is you're splitting up your combi file. So you're splitting up your combi file, which is a combination of the train file and test file. So 31962, that's the number of files in the train file. So train bow goes up to 31962, and test bow goes from 31962 to the end. And so now what they do is they split the combi file up into sections, and basically 70% of it is going to be trained on and 30% of it is going to be tested on. And so what they've done is since they've split the combi file up, what they've done is they've called, normally this would be X train X test, Y train Y test. But what they've done is they've taken like the test file and called it label. So all of the predictions are going to go into this column called label. So now we've created our logistic regression, which I covered in one of my recent videos. And in the logistic regression, in order to get the accuracy up, what I did was I used a grid search mechanism. So the grid search mechanism wasn't actually in the course, but I went and researched it and added it to the course. And basically, it brought it up 2 points. It brought the accuracy up 2 points, which is good when you're entering competitions. And I will say that I tried to use grid search on the other algorithms, but I don't know enough to do it. So I abandoned the project because I don't know enough and I'll have to learn some more. And then so we go through here. This was your grid search, everything that the grid search did, but it gave me 2 additional points. So then you've got your best model equals predict equals test bow. So that's way they're training on the test file. So you've got some more grid search parameters, which were added when I added grid search. So now we're predicting on it. And it had, I put it into the system and it had like a 94 no, sorry, 54%, which whenever I added the grid search, it brought it up to 56%. So this is your sample, this is your submission file. And if you go in here into files, it would be, I mean, I don't want to mess around with it too much, but if I had run the code, which I'm not going to run the code because it takes a really long time for the system to run through, over here in sample data, the actual submission files would have been created. And then what you would be able to do is you would download the submission files. And then when you downloaded the submission files, you could submit them to Analytics VidHire. Okay, so then there's some more code that they put in after they did the submission file. Don't ask me why they did that, but you get some more code. So this one was TF-IDF, and this one was Word to VEC, and this was Doc to VEC. Now we've got SVC. I could not get the SVC to run, but I decided to go ahead and leave the code in there, even though I couldn't get it to run, and I just put it all in remarks. So if anybody wants to try to get it to run, good luck, but it just wouldn't run. And that's one of my complaints, is the fact that you couldn't get it to run. And so if you can't get it to run, why use it? So the next algorithm we used was random forest, and we did actually get random forest to work. So I submitted random forest to the system, and it was still in the 50s, or I don't remember exactly what it was, but it was still in the 50s, so it still wasn't great. And here's these more features that they put in, and don't ask me why they put the features in after they did the submission file, but they did. And then so now what we've done is we've gone to XGB. So bag of words features, that's where they have XGB. And they set up the XGB classifier, and they fit it in the same line, and they predicted it, and they gave you your F1 score, and they prepared the submission. So this is your XGB. And whenever I put XGB into the system, it was very low. It was about 54%. And the reason why is because you're supposed to fine tune XGB. So they put these other files in here, other code in here. Don't ask me why they put it in after they did the submission, but they did. And then what they wanted to do was they wanted to fine-tune XGB. So if you fine-tune XGB, then you're supposed to get a much better score. And so in order to get XGB to work, you have to prepare the file. So dtrain equals XGB dmatrix, dvalid equals XGB dmatrix, and dtest equals XGB dmatrix. And what that does is that converts the file into another format that can be used by XGB, which is extreme gradient boosting. So we set our parameters, we defined another function, we tuned the max depth and min child weight, we updated our parameters, and we did a cross-validation. And then when we did the cross-validation, I got a message saying tuple object is not callable. And that's basically something that I was getting with the other modules as well. And by this time, it was like close to midnight. I'd been working all day on it. I was exhausted. Even my boyfriend was tired, and I said, I can't do any more on this. I don't know enough. So I put it away and just decided that I would do a cold review on it. And see, that's the problem that I have whenever I get this code from the internet or take a course and get the code. quite often the code doesn't work and I have to troubleshoot it. But I don't know enough to troubleshoot a lot of these things. So I can look it up on the internet and try to find the solution to the internet. But it's difficult. It really is difficult. And so I just thought, well, I'm not going to carry on with this anymore, because the last time when we did the loan prediction, the XGB didn't work with loan prediction either. So we did some more code, which the interpreter didn't even get to because it stopped at the one point. So we updated the max depth and min child parameters. We tuned subsample and co-sample. We updated the parameters. We did some more cross-validation, found the best F1 score, updated sample and co-sample by tree, tuned the learning rate. We ran cross-validation again, find the best F1 score, final list of tuning parameters, and then you could set up your parameters and prepare the test file, which the system didn't prepare the test file because it crashed on me. But I just still wanted to do this code review and show you the code review, and maybe if I learn more, then I'll be able to correct this problem. But at the moment, I won't be able to. And that's something that really aggrieves me, because I take these courses to get the code and to learn about the subject, and the code doesn't work. And I spend most of my time actually troubleshooting the code. But since I'm still learning, I don't know enough to adequately troubleshoot the code. So I'm definitely not going to take any courses that you have to pay for if the code that they give you is faulty. So that concludes it for my code review. If you like this video, please like, subscribe, and share. If you like the work I do, I've got my email address down below. So if you want to make a donation to my PayPal account, it will be very greatly received. My benefits that I receive haven't increased since 2015 when I got them, because number one, we started austerity. Austerity was supposed to finish in 2020, and then we had the coronavirus lockdown, which crashed the economy. I was reading something in the news that the UK debt has entered into the trillions. So that's just going to be another excuse for the UK government to extend austerity, because they've already said that they're going to use the coronavirus as an excuse to extend austerity. So that means they're going to cut even more services to vulnerable people, who are the ones who need these services the most. So any donations will be very gratefully received. Thank you so much for watching this video, and I hope to see you the next one.